Good morning, everyone. My name is Sam McGee. I'm a certified occupational hygienist and senior occupational hygiene consultant here at ChemSafety. I've been doing occupational hygiene with ChemSafety for the last 13 years. Doesn't feel that long. And today we're going to be doing a webinar on controlling exposure to wood dust. So there's a little bit of an interactive portion at the start, and where I'll get you to use your phone to scan a QR code and answer some questions, and then we have space at the end for some questions and answers. If I can't get them to you today, we'll be able to email the answers back out to you guys. And a recording will be put up on YouTube. So let's get started. So what are we covering today? Why do we even care about wood dust in the first place? Why am I doing a webinar on it? How we are getting exposed to wood dust? And how do we use controls to lower our exposure to wood dust? So to start off with, I've got some interactive parts here to get an understanding of where you guys are, how you're exposed to wood dust, etc. So there should be a QR code that you guys can see on the screen here to mentimeter.com. And I believe when you enter that code in as well, you'll be able to answer some questions and we'll be able to see some of the answers here shortly. So I'll just give you some time there to answer these questions and we'll see what the word cloud spits up about what industries that you guys work in and how you might be exposed to wood dust. Awesome, I can see some answers coming through here. So I'll just give it a moment. So as we're getting quite a range at the moment, as ones become more common or frequent, they'll get bolder in this word cloud. So we'll just give it a little bit more time. And thank you for participating. It makes it a lot easier on my part. So you can see here, construction and forestry starting to come to the fore. As you could expect, forestry is where we get our wood from in the first place. Construction, we often use wooden materials. Food manufacturing, occupational health, so health nurses, hygienists, etc. What else do we have here? Tertiary education, sawmilling, that makes a lot of sense. Universities, buildings, wood manufacturer, joinery, yeah, all really common areas where we can see wood dust. That is fantastic. So I'll try and tailor examples where appropriate to some of these sectors. Port industry, yeah, a lot of wood gets exported, whether it's the bulk logs or the finished materials, and you can see them piled up at ports around the country. Awesome. Thanks for that. And by all means, yeah, keep filling out those questions there. We'll move on to the next one. Hopefully you have answers to that too. So this one here is, what tasks do you do that expose you to wood dust? So we're sort of talking, we know what industry you're in. Are you drilling, cutting, routing, sanding, etc.? So if you could start answering that question as well, it might be a separate QR code. That's coming in here. Awesome. Give it a couple more moments. Cutting, really obvious one there. It's how we predominantly get exposed to wood, is by cutting it. Sanding, planing, building inspections, grinding wood, boiler operation, yep, biomass boilers, wood pellets, sawdust, offcuts, all those can be used. Shredding fibre, drilling as well, cutting, felling trees, yep, makes a lot of sense there. Planing, sanding, yeah, just what I anticipated, but it's good to see it's coming through here in the data. A couple more moments for the last few people to respond. So CNC dimension source, sanding, yep, CNC machines. Great that you can sort of leave them to be, but they do create a lot of dust. Observations. Awesome, thank you guys. All right, let's see what we've got on our next slide. And this one is asking, what controls do you have? So what measures are you taking currently to reduce your wood dust exposure? extraction, fantastic. P2 masks, PPE, respirators, yep. So I'm seeing a lot of PPE and extraction here. So we've got medium, not the highest order control of elimination, but we've got extraction, which is still pretty high up there, and we've got PPE, one of the lower order controls, but absolutely is needed in a lot of cases. Machine specific extraction, isolation, health monitoring, that's fantastic. Cleaning, misting, for dust suppression, that's awesome. Workshop vac. Uh, yeah, lots of great answers there. So I'm good to see that there's a range of controls already being done. So that is fantastic. Thank you for filling those out, guys. Helps me with the presentation. So, why do we care about wood dust? Why am I doing this webinar in the first place? So, the main reason I chose to do wood dust as a topic for this webinar is from January to March 2026, WorkSafe inspectors are going across the country doing proactive assessments that focus on the wood product manufacturing subsector. These visits aim to help businesses understand their health and safety responsibilities and manage critical risks such as machinery safety, work exposure to toxic dusts, fumes, chemicals, and hazardous substances. So that worker exposure to toxic dust and fumes, chemicals, that's where I come in as an occupational hygienist. So what is a common building product used in New Zealand and is a vital part of our economy that employs thousands of people in many sectors? So I've just noted here that we've got 1.82 million hectares of planted production forests. So, those are just the forests that we're going to be felling and using to make timber, other products out there, mostly pine. And we've got over 5,000 people employed in the forestry sector and a further 17,000 people that work in wood product manufacturing at the last census, let alone all the builders, construction workers, people that work in waste products and landscaping, etc., that are still going to be exposed to wood dust. And it's not just workplace exposure. We've also got our DIY, our home exposure. People that are hobby woodturners, etc., are still going to be exposed even if it's not their workplace. And wood dust exposure can cause a range of occupational health issues. So we can talk about asthma, respiratory irritation, eye irritation, dermatitis. Some wood types are sensitizers, which means a small dose will lead to eventually quite a large health effect. Hardwood dust can cause cancers, in particular sinonasal cancer. So there's a range of health effects that wood dust cause, and it has quite a burden on New Zealanders. Now, these stats here aren't specific for wood dust, but wood dust will play a part here. New Zealand has 750 to 900 deaths per year due to work-related health issues. So that's not a crash or an incident, that's a disease or a similar cancer process that's caused someone to die. And a further 5,000 to 6,000 hospitalizations due to those work-related health issues every year. So that's why we need to do something about it. Those are numbers that we definitely want to reduce. So when we're assessing wood dust, we often compare it to exposure standards, our workplace exposure standards. And for wood dust, we split that into two categories, softwood and hardwood. Now, they're not quite as simple as you're seeing. These softwood and hardwood distinctions are based on its cellular structure. It's a botanical distinction, and it isn't directly based on the wood's hardness, although it mostly follows. There are some pretty unusual examples where a balsa wood, for example, is a hardwood, despite it being a very soft and light wood. And it's not specifically based on its density. Softwoods are gymnosperms, saying that correctly, which means they have naked seeds, typically cones, as you can see in this picture here, and tend to have needle-like leaves as well. So common species of softwood that you'll come across and you have come across in New Zealand are pine. Most of our wood dust is going to be pine dust, Douglas fir, macrocarpa, lark, rimu, totara, kauri. And our workplace exposure standard, which I'll talk to a little bit more detail later is 2 milligrams per meter cubed. So that's the limit we can have for 8 hours a day, 5 days a week, um, working year, working career, and most people should be totally safe. On the opposite end of the spectrum, so we've got our softwoods, we also have our hardwoods. Now, hardwoods are angiosperms, which means they have enclosed seeds, typically in the shape of, in the form of fruit or nuts. So kind of like an oak tree with its acorn nut. And they tend to have broad leaves and are deciduous. So hardwoods typically grow slower and have stronger, denser woods than softwoods, although it's not a hard and fast rule. Hardwood dust is a sensitizer. That means that once a person is sensitized, and they can take a long time to become sensitized, a very small exposure can cause quite large health effects. And hardwood dust is also carcinogen and is linked to sinonasal cancer, whereas the evidence for softwood dust and carcinogenity is a little more up in debate. So some hardwood species you're likely to come across: eucalyptus or blue gum, silver beech, red beech, tawa, and rata. And the workplace exposure standard for hardwood is 0.5 milligrams per cubic meter. So when we compare that back to the previous slide with softwood with 2 milligrams per cubic meter, we can see that the hardwood dust is a lot lower, a lot more stringent to meet there. So I talked about these. We'll just go a bit more detail to make sure we understand them. Workplace exposure standards are guidance values, or we sometimes shorten them as WES, that are set by WorkSafe New Zealand. These are concentrations in ppm, parts per million, parts per billion, ppb, or milligrams per meter cubed. And these should mean that most workers can be repeatedly exposed to this concentration without coming to harm. Now, these are designed for guidelines for health risk monitoring by trained people. They are not a legislative requirement that you must be under, but it's showing good practice if you can be under these levels. And we have three main type of exposure standards. We have a time-weighted average, a short-term exposure limit, and a ceiling limit. When we are talking about wood dust, they only have time-weighted average exposures. Their health effects are based off a chronic, long-term condition. That's why we want to protect with an average exposure limit, as opposed to an acute effect that we might try to protect from with a STEL or ceiling limit. So, how are we getting exposed to wood dust? Now, you guys gave some great examples earlier, the tasks you're doing, the industries you're in, and how you've been exposed. And yeah, my tip here is quite similar to what you guys provided there. So great that we've got this on the map. Forestry makes sense. We're cutting down the trees. Sawmills, where we're processing the logs into timber. Joinery, so we're making our kitchens, we're making our wooden structures from that. Furniture manufacture, we're making our beds, our tables, our chairs, etc. Organic waste, so all the trees we cut down and we give to the organic waste dump, they've got to crush that, shred that, do whatever they do with that organic waste, so they're being exposed to dust there. Landscaping, you're dealing with bark, your trees, etc., so you are exposed. Ports, someone mentioned there earlier, and on that Mentimeter, ports, we store a lot of our logs there, we store a lot of our timber, piles of bark and sawdust are also quite common at port sites. And I've definitely done jobs where it's adjacent to the port, but they're worried about the dust coming across the boundary with the wind there and how that affects their workers. Construction, obvious, a lot of our houses are still built with timber framing. So there's a lot of exposure there in the construction industry. Pulp and paper, paper's made out of wood, so we've got to get that wood and turn it into paper. So there's a lot of exposure there too. There are also some areas that I've been involved with doing wood dust exposure assessments where it's not as typical as you'd expect. Food exporting, where the product is packed in a wood wool, sort of insulating protective layer before being shipped overseas for export. So that there was a case where they've been exposed to the wood wool dust in that process. I've also done an artist studio where they did a lot of wood carving with some exotic hardwoods, and they were exposed there because it was a large part of their job. And not industries you immediately think of as wood dust exposure, but absolutely are. So Some high exposure tasks. WorkSafe have guidance out on wood dust exposure, and these are some of the tasks they highlight. And lo and behold, they're actually the same as the tasks that you guys identified yourself. So sawing and cutting of timbers, routing and turning of timbers, sanding, dry sweeping of dust. So whenever possible, we want to, getting ahead of myself here, but we want to vacuum the dust. We don't want to be sweeping it or blowing it away. Compressed air cleaning. Been to a lot of factories, wood product factories, where at the end of the day, the workers are coated in wood dust. What they do is they go find a compressed air bit and they blow themselves clean. That is an awful thing in terms of exposure. Not only have we got the safety issues of potential compressed air injuries, but we're just disturbing all that dust and letting it get up in the air again and giving it time to spread out and being exposed to it again, whereas it's relatively settled when it's on our clothes. We also might have situations where they've got some great on-tool extraction, but that extraction ends up in a bag, and that bag needs to be emptied and replaced. So despite that great, they're capturing it there, they then take it outside and tip it into the skip, creating a lot of exposure in that task there. And it might not all be workplace exposure. There are a lot of hobby wood turners out there in their sheds, etc. So you can be getting exposures at home as well. So we got some data here about what are some high exposure tasks. Now, this data is from the HSE, which is the UK's version of WorkSafe. And they do some proactive sort of studies. And in a period between 2014 and 2017, they did this research report into wood dust exposures in manufacturing, perfect for what we're covering today. And these are some of the levels they found. So as we can see here, all these tasks are above what is the wood dust exposure standard, the median exposure there. Because if we go back to the hardwood dust, we've got 0.5 milligrams per meter cubed. That's our workplace exposure standard. So that's the average level that we should be above. And we look at these job categories: bandsaw, circular saw, routing, sanding, assembly, cleaning and maintenance, all of them above, if it was hardwood, 0.5 milligrams per meter cubed. So they'd all be well in exceedance of that exposure standard. If it was softwood dust, which has a standard of 2 milligrams per meter cubed, the only one where the median average exposure would be over is the sanding task. But if we look at some of those 90th percentiles, they're all actually, or those that we have enough data for, they're all above that softwood and hardwood exposure standards of 2 and 0.5 milligrams per meter cubed. The task exposure also sort of makes sense. Assembly is, screwing, nailing, gluing together pieces of timber, etc. So we're not as much sawing or cutting as we are in those other products. So it makes sense that exposure is at the lower end. Whereas something like sanding, we know sanding is a dusty process, so we do expect that to have the higher exposure. And the reason why that 90th percentile matters is, these are only a small number of data points. If you're sanding every day, different pieces of wood, different conditions, there'll be a range of actual exposures. And we've got to make sure we're protecting across that range, not just in the middle. Hence why we look more at the 90th or 95th percentile of these exposures. So, and just going back to those exposure tasks there, these levels are similar to what we find here in New Zealand. Obviously, I can't share our clients' data when we do our monitoring out here with you all, but these are not atypical to what we find. Sometimes we've even found levels that are a lot higher than this. So how do we use controls to lower our wood dust exposure? These are AI images, so they're not perfect, but they get the point across. We want to go from the situation on the left to the situation on the right. This to that. Now, as you can see there on the left, this workshop is caked in wood dust. It's everywhere. If you're doing anything in that workshop, you're going to get exposed. Whereas the situation on the right, you can see they've tried to put in, AI's tried to put in some local exhaust ventilation, some on-tool extraction. You've got some bagged asbestos wood dust at the back there. So we've got some controls in place. We can also walk into that workshop and not create a cloud of dust where we go. And we might look at a site and be like, that's not too dusty. But, at home, if you've got a small gap in your curtains and the light's shining through and you can see all the dust in that gap, Same thing with dust. What we can see is only a tiny portion of what's actually in the air. If you had that bright light, you would be able to see a lot more airborne than what actually is there to the naked eye in normal conditions. So I'm going to cover a few general control principles and then we'll apply them to wood dust at the end here. So we should all be familiar with this. It's the hierarchy of controls. It's specified in our legislation, the Health and Safety at Work Act. We go from elimination, which is the most effective, substitution, isolation, engineering controls, administrative controls, and PPE. So we go from most to least effective. Now, often these lower order controls are quicker and easier to implement. So they get done first, while the company then works out the capital requirements to build a ventilation system or to investigate a new product that will substitute or eliminate the hazard. We also have the source path receiver model. So the controls are going to be the most effective when they're used at the source of the exposure. Then the next tier down is at the path of exposure. And finally, they'll be the least effective when we're controlling at the person because the hazard has already got into the person. The chance of that control working is, if that fails, the exposure's there. Whereas in the other two, if it fails, we've still got other points where we can try and capture the exposure. But controlling at the person is a lot easier to get them to wear PPE. Controlling at the source can be a lot more difficult and a lot more expensive. So I've worked a little picture diagram here of the situation just to explain how these work in practice. So we've got the worker on the left there that is cutting down a tree, and we've got another worker on the right who isn't. So if we try to control at the source, we could put in some local exhaust ventilation, capturing that wood dust at the moment it's generated when we're sawing, cutting through that, felling that tree, cutting through that timber, and stopping it from getting to both the workers. Now, it can be difficult when the worker is really close to the source to be able to control the path, but that is definitely something we can do in the for adjacent workers. We've got a lot more opportunities to control the exposure and the path. Because this is outdoors, increasing ventilation, etc., isn't really practical because we're at the mercy of the Mother Nature there. Whereas we could create a water misting system here to capture the dust that is missed by the product at the source and is traveling across to that worker on the right. Now, the thing with dust and misting suppression is that the water droplets need to be as close in size to the dust particles that you're trying to get out of the air, to get out of suspension. Just gets into the aerodynamics and physics of the interaction, but if they're at similar size, they will all come out of the air. If the particles are too big or too small, they won't have the desired effect on capturing the wood dust, and the wood dust can get through back to the worker. So it's something to be aware of when doing a misting solution, is to make sure that the water particle size is of a similar size to the dust that you're trying to capture. And then a final option is controlling at the person. So we can see now that these people have respiratory protection on. So if our wood dust has escaped our local exhaust ventilation and it's got past our misting scenario, both workers have respiratory protection. So the wood dust has to get through the filters on that respiratory protection to be able to protect them. So it's often a lot easier to control the person. But as I said earlier, if that person's not clean shaven or the wrong type of filters or the mask is broken, then if we just have that one level of control that fails, the person is going to be exposed. Whereas if we have multiple layers, which we're going to talk about now, the Swiss cheese model, it might not lead to exposure. So then we have the Swiss cheese model, which you may have heard of before as well. So no control measure apart from elimination is perfect. If you think of each control measure as a piece of Swiss cheese, each control measure has its flaws or weak points, but if you have enough layers of controls, then you minimize the likelihood of all the weak points aligning and leading to exposure to your worker in this case. So I've added some examples here. We've got our worker on one side and we've got our exposure on the other. We have some engineering controls in place, but you can see these three purple dots here are where those particular ones weren't serviced in time. So they weren't working effectively and the exposure got through. Then we can see here we've got some administrative controls, such as training on how to make sure the machines are operational, that they've been serviced, and some hazards, training on the hazards of the wood dust, as well as how to use your PPE effectively. Now, some people weren't there on the training day, so you can see that exposure got through, but we still see the person was wearing PPE correctly, so they're no longer exposed. That final layer of Swiss cheese was able to stop that exposure from happening. So we want a multi-layered approach with our controls. So going down the hazard hierarchy with some specifics about wood dust exposure and its controls. We've got elimination and substitution. Now, elimination is not normally practical. If your job is to cut down the trees in the forestry block, well, you know, the trees have to be cut down. Or if you're making wooden furniture, you have to make wooden furniture as a business. It's hard to not do that and still be an effective business. But in some cases, it can be done. If wood is only a small part of your product that you're manufacturing and you only need one particular size of wood, you could get those panels bought and pre-cut to the right size and dimensions for you. So that leads to no more cutting and exposure on site. Niche case, but can be done. Substitution can be done in some circumstances. So if we're working off hardwoods, but there was suitable softwoods that have the less severe health effects that we could use, we could substitute from a blue gum piece of timber to a piece of pine and reduce our exposure there. We could also change the form of the wood. So if we're using a biomass boiler and we had just pure sawdust used as our product, but instead we could use this pelletized form, like you can see in some of those low emission burners, then we've changed the form. That pelletized form is a lot less dusty than pure sawdust. So we've substituted to a less hazardous form of the product as opposed to changing our product overall. It's the exact same wood, just in a less dusty version of it. Isolation and engineering controls. This is often what we'll see on site and was what a lot of you guys had as the controls you're currently using. So local exhaust ventilation or on-tool extraction. These are great systems. We're trying to capture it at the source or as close to the source as possible. So there are a lot of sanding discs now, orbital sanders that have a little hole in the center of the orbital sander where the air gets drawn in and the dust gets collected out in a baghouse system. So that's fantastic on tool extraction. Not all tools are going to be perfect with that, but many can be adapted. Where those can't, we can try use local exhaust ventilation, but it's got to be suitably designed. If we're using a circular saw, those wood dust particles are going to be flying out in a particular direction at a quite high velocity. So we're going to need to make sure that we're capturing it in the right direction with a sufficient velocity of air movement to pull them in as opposed to them just blowing right past. These engineering controls are often expensive and take a lot of ongoing servicing and maintenance to make sure they are running effectively. I've seen some situations where they've absolutely installed some amazing control systems, but never have they been maintained, had the filters changed, and they've just caked up and basically pulling no anymore. They're not effective. And that can lead to a false sense of security for the workers because they think this control is there protecting them. They might not use PPE anymore, but realistically, that control stopped protecting them a long time ago. Having designated cutting areas or booths is fantastic. If wood cutting is only a small part of your process, having it in a designated area which is controlled and stops the wood dust from spreading to other areas of your facility will absolutely help reduce exposure. And it makes it easier for you to manage the exposure of those workers that are in there. General ventilation. So this is going to be a lot more effective in indoor facilities, factories, etc., are not so relevant in a forestry block. But increasing the ventilation is going to decrease the concentration of the wood dust in the air, and is great to be used in combination with local exhaust ventilation or on-tool extraction. Water misting, as I said earlier, you want the droplets to be the similar size as the particles that you're trying to capture out of the air. And industrial vacuums are definitely recommended. We shouldn't be dry sweeping wood dust. We shouldn't be using compressed air to blow it all down and sweep it up. We want to be capturing it. We want to HEPA industrial vacuum. That's the right grade for wood dust. That's something we can advise you on, be it based on your particular situation. and we want to, control processes, how we clean and empty that vacuum cleaner as well. Administration controls. These are controls that aim to change the behavior of the workers in order to reduce their exposure. So doing something carefully, cleaning up as they go, as opposed to, just rough cutting, not caring about the dust and leaving it everywhere. So good housekeeping will tend to lead to lower exposures. So we could have cleaning policies, training requirements, training the staff on how to use their controls, how to use the LEV, how to change the filters, how to make sure it's working properly, how to use their PPE. We can do exposure monitoring to check that our controls are valid, including health monitoring as well. So, you can have your workers do lung function tests to make sure that they're not being exposed, and if there is some exposure or some decrease in their lung function, that they're being tested and treated for that quickly, as opposed to just going on in the background. Exposure monitoring can be done pre and post implementing controls. All right, our exposure was at 20 milligrams per meter cubed, but we put in local exhaust ventilation. We got rid of compressed air cleaning. We use industrial vacuum cleaners. We were in RPE, and we've dropped our exposure down to 2 milligrams per meter cubed. That's fantastic. Pardon me. These are the things where exposure monitoring can be really useful, and in a situation where your controls have been in place for a while, that they're still as effective as they were when they were first introduced. As time as equipment ages, it may get less effective. So this is a way to validate that it is still protecting your workers. PPE was often one of the common ones you saw there. So for particulates, wood dust can be covered by P1 or P2 filters. P2 is great. It's a high-level filtration, so if your worker can tolerate P2, I definitely recommend that if they need it. These are cheaper and easier to run in the first instance. So if you've just discovered you have a wood dust problem, we can get some PPE in while we figure out all the other controls that we need to put in place to reduce our exposure. So we have a lot of options of PPE. For some work sites, a powered air purifying respirator, like the picture on the bottom left, is fantastic. They are a lot more expensive, but they draw in filtered air and push it over the face, and therefore there's less demand on the respiratory system compared to something like the negative pressure respirator in the center there. That one we have to physically breathe in through the filter, so that puts a lot more strain on our respiratory system. So if we're doing a lot of other physical work, which a lot of these would, think of cutting down a tree or that, we want to be able to make sure we're not overtaxing the respiratory system of the worker. Our PPE also has to be considered the other hazards. Like this webinar is just on wood dust, but if we're talking furniture manufacturing, we've got solvents from the glues, the adhesives, etc., that are used, the paints, the oils. We've got noise in all these products, so we could be wearing hearing protection. We've got to consider these other factors too to make sure our PPE is protecting the worker as a whole. If we're wearing PPE, we're going to have to be clean shaven. You can see this diagram of a human hair. They're 40 to 120 micrometers in diameter. Fine dust, PM10. I see those little yellow dots around that blue circle. Those are sort of what we're looking at there. So very fine dust components. So they're the little blue circles on that picture there. So if we are wearing respiratory protection, tight-fitting respiratory protection, and we're not clean-shaven like myself, there's no point in saying that's protecting our worker. There's a lot of gaps for the wood dust to get in and be exposed. So that's why fit testing is important, them understanding why they need to be clean-shaven when they're wearing respiratory protection. And if that worker's not going to be clean-shaven, then you want to look at other controls like local exhaust ventilation or powered air purifying respirator. There are things that they can do and still have their beard and still be protected. So, some key takeaway messages, and we'll have some time for some questions. Wood dust exposure is common in New Zealand workplaces. I've seen a lot of workplaces that have quite high wood dust levels, and a lot of them we've gotten down, but there's a lot more workplaces out there. And wood dust can cause a range of health effects that are quite nasty. Asthma, respiratory irritation, skin and eye irritation, cancers. These are things we don't want to have, and we can avoid this as well. And there are controls available that we can use to reduce our exposure. If we can change from hardwoods to softwoods, if we can isolate, if we can automize, so we're actually getting people away. Administrative control I didn't talk about earlier was job rotation. So if you have a task that's going to lead to exposure, we could have the staff rotate through that job, so no staff has been exposed the whole time. But we're going to need a combination of these controls to protect workers in most instances. And whatever controls you use, it's important to train your workers in how to use them, how to make sure they're still going effectively, and we need to monitor their effectiveness. So we have a slide for questions. And feel free to ask some questions here in the chat. Do we have data for the New Zealand context? There was some data from 1992, but there was more in the sort of forestry section. I decided to go for some relevant data with current control practices there. Yes, someone has raised a hand. I'm not sure we have the ability for audio questions, so if you could just type your question in, that would be fantastic in the chat. Give you a few more moments, and if you have questions that you don't want publicly put out there, feel free to email us afterwards. There will be some information coming out. Yeah. So, what hardwoods are the most toxic? I don't know off the top of my head. I know there are ones that are more likely to cause cancer than others. A lot of the studies into hardwood toxicity have been done overseas, so they're not typically talking about timbers that are found in New Zealand, like kauri or rata. Yeah, but I can try provide some in that email there. They're normally, exotic species to us here in New Zealand, but typically hardwoods do cause those cancer effects. How do we get the beard dyes clean shaved one there? How do we get beard dyes to get clean shaven when their fit is good? So getting people clean shaven is that needs to be done for the fit test. They won't be passed a single fit test if they've got any facial hair. So when we're doing fit testing, it's ideally shaved within the last 12 hours, but at least 24. And it's up to the person doing the fit testing if it looks like this person has a 3 o'clock shadow, that actually no, they're going to need to go shave again before the fit test. And then that fit test is only relevant for when they are clean shaven. It does not take much hair growth at all before the effectiveness of the respirator decreases sufficiently. Which is worse, MDF or plywood dust? MDF they both have adhesives and other products in them that can depend. So it depends on the specific manufacturer of that MDF or plywood in terms of what adhesives or binders are in there. So MDF often will have formaldehyde, which is quite bad for you. But if it's been a long time since it's been manufactured, it's sat there, a lot of these products have off-gassed. So there is a lot of factors to consider there. Pure wood is going to be safer than MDF or plywood, but obviously they have their own structural purposes where they're going to be used. So rather than just P2 filters, we might be looking at combination filters for organic vapor, gloves, and other protection. So it really depends a bit more specifically on your scenario there. Water controls on wood and wood dust. How do we manage mold for the longer term? Yes, so that is absolutely an issue and something that needs to be considered. It works well in a situation like the wood wall packing, where it's a short-term exposure. So this product isn't designed for long life. This product gets exported. If the wood wall is wet, the wood wall is at the end of its life in about 48 hours later, so it doesn't have time for the mold to grow and proliferate. Outdoor situations, potentially a bit more better, but indoor furniture workshop, you probably don't want to be introducing water to reduce because of that increased biological mold risk there. What do you believe WorkSafe will focus on with their inspections? Most attendees, including ourselves, show multiple controls are already in place. Yeah, I've definitely heard of some facilities that have had the inspection and have basically passed. They've shown they've got controls, but there are a lot of people with these health effects that are coming up in a lot of areas that aren't exposed. I'm aware of, timber processing places that haven't had health monitoring done. So that's a control that could easily be improved upon. They haven't done exposure monitoring in the past. The local exhaust is sufficient, but it's all about getting multiple controls and lifting that bar of exposure. We can always do better to protect our workers there. For P1 and P2 mask, clean shaven is needed. Yes, so for any tight fitting respirator, I don't have one with me right now, an arm's reach, any tight fitting respirator they need that's negative pressure, or any tight fitting, whether it's positive or negative pressure, there's a tight seal on the face, then they need to be clean shaven. The only ones that don't need the workers to be clean shaven are positive pressure ones, which they're not tight fitting, they're loose fitting, and they blow air past the face from a filter on the backpack typically. And when I say clean shaven, it's clean shaven in the surface area of the sealing area of the mask. So there are some styles of mustache and a goatee that might be suitable depending on the mask, but basically there can be no hair between the sealing surface and the face. The sealing surface of the mask has to be directly on the skin. This question here, could those do fit testing please test non-shaven people to prove they need to shave? As a nurse testing, we see people that were shaven when tested but then stopped. So the method says we aren't allowed. The standards we are testing to say we're not allowed to do fit testing when they have facial hair. It's just not a valid assessment of that method. Just because they have facial hair on one day, it changes its shape, it changes in length. So there's no point in testing there because, in the off chance they do pass, then it's a false sense of security, whereas the next day, same beard will fail. No fit testing should be done when they're shaven, when they're bearded at all. This one here, our workers do not handle wood piles directly. However, during dry periods, they operate water suppression trucks to control dust spreading across different areas of the port. In this situation, would all personnel be required to wear masks? Dust monitoring can be challenging to carry out at the optimal time, as conditions are not always consistent. Sometimes it's dry without wind, other times there's wind with no significant dust generation. Yes, that is difficult. So I guess the simple answer is it depends. But if they're in a truck, a cab, where there are other controls we can go to that are going to be more effective than wearing respiratory protection. So we can make it be a filtered cab, which has filtered air systems that will protect the worker from not just wood dust, but a lot of dust, coal, cement, whatever else may be on the port facilities there. And that can be a lot easier than making workers wear PPE and while they're driving all day, because they might feel that is overburden or ridiculous when they're sitting inside an enclosed cab. But if we can measure and make sure that their cab is sealed and got the right sort of filtration system, then you wouldn't need PPE. We've used a higher order control and you can do monitoring to prove that it's good inside the cab. Awesome. That seems to be all the questions we have here. So there will be a recording of this put up online on YouTube and some information will be sent out later. Thank you very much and have a great day.